Once again back to my YouTube channel Sriram Devarajan. Today I am going to discuss another set of problem from KSET Mathematical Science question paper from the year 2013. This is part 4 of my video for the year 2013. I already uploaded part 1, part 2, part 3 from the year 2013 KSET Mathematical Science question paper. You just go to my YouTube channel, check the playlist. You may get KSET 2013 previous videos consist of part 1, part 2, part 3. Today I am going to discuss another set of problem. The first problem, let T maps R square to R cube be defined by T of x comma y, which is equal to x plus y comma x minus y comma y, then the dimension of the range space R of T is option A 0, option B 1, option C 2, option D 3. In this problem, T is defined by T of x comma y, which is equal to x plus y, x minus y, y. Then we have to find the dimension of the range space R of T. Dimension of the range space R of T is nothing but rank of T. Solution, we have to find only the rank for T. Since T maps from R square to R cube, the standard basis for R2 is 1, 0 and 0, 1. Find first of all T of 1, 0. That means x is 1, y is 0. X plus y becomes 1, 1, 0. Now find T of 0, 1. Here x is 0, y is 1. 1, minus 1, 1. Now write matrix. Write 1, 1, 0 in the form of column 1, 1, 0. Second column 1, minus 1, 1. Find the rank of T. Write this one as in echelon form. Make this one as 0. That means R2 minus R1. 1, 1, 0 minus 2, 0, 1. Now 1, 1, 0 minus 2, write R3, 2 R3 plus R2. it becomes last row 0 0. For finding rank, number of non-zero row in echelon form. Here first row non-zero row, second row non-zero row. Number of non-zero in echelon form is 2. Therefore rank of T is 2. For this problem, option C is the correct one. Second problem. Which of the following mapping is a linear transformation? Option A, F maps from R square to R square defined by f of x comma y, which is equivalent to x cube comma y cube. Option B, F maps R3 to R2 defined by f of x comma y comma z, which is equivalent to z comma x plus y. F maps R square to R defined by f of x comma y equal to modulus of x minus y. Option D, F maps from R square to R square defined by f of x comma y x plus 1 comma y plus 1. Here 4 options is given. We have to check which of the option among the 4 is a linear transformation. Solution. In the first option, f maps R square to R square defined by f of x comma y, which is equivalent to x cube comma y cube. For linear transformation, the degree must be 1, but here the degree of x is 3, degree of y is 3, therefore not a linear transformation. Option A, wrong one. Option B, what is given? F of x comma y comma z, z comma x plus y. If I give values for x0, y0, z0, f of 0 comma 0, it becomes 0 comma 0, which is 0. Therefore, for proving any mapping is a linear transformation, straight away if you give values for x, y, z as 0, if you get f of 0 as 0, then we can say it is a linear. Option B, linear. See, in the option D, if I give values for, this is option B, this is option A, option D, if I give values for x and y as 0, I am getting 1, 1, not 0, 0. Therefore, option D, not a linear transformation. Option D, not a linear transformation. See, option C, what is given? F of x comma y is given as modulus of x minus y, which is less than or equal to some modulus of x, some modulus of y. See, for linear, it should be equivalent to, only equivalent to, not less than or equivalent to. But here it is in the form of modulus. I am writing in the form of inequality. If it is a equality, then we can say it is a linear transformation. Since for modulus we are using less than or equal to, therefore option C is also not a linear transformation. For this problem, only option D is the third problem. The series summation n equal to 1 to infinity 1 by n power p is divergent for what values of p? Option 1, that is option A, p greater than or equal to 1. Option B, p greater than 1. Option C, p less than or equal to 1. Option D, p less than 1. The series is given as summation n equal to 1 to infinity 1 by n power p. The series is divergent for what values of p? 4 options are given. Straight away by p test we can say for the values of p which is convergent, or what values of p whether it is convergent or divergent. Solution: summation 1 by n power p n equal to 1 to infinity, if the series convergent if p greater than 1. The same series divergent if p less than or equal to 1. This is p test. Therefore option C is the correct option. For p less than or equal to 1, the series summation 1 by n power p is divergent. Fourth problem: what is set of eigenvalues of the matrix 1 1 3 1 5 1 3 1 1. Option A 2 3 6. Option B 2 6 7. Option C -2 3 6. Option D 1 3 6. For solution for this 3 cross 3 matrix, we have to find the eigenvalue. For 3 cross 3 matrix, there should be 3 eigenvalue: lambda 1, lambda 2, lambda 3. By well-known result, trace, which is equivalent to sum of the diagonal, which is equivalent to sum of the eigenvalue, product of eigenvalue, which is equivalent to determinant. See, trace is sum of the diagonals 1 5 1. If we add trace 1 plus 5 plus 1, answer is 7. And also determinant, which is equivalent to 1 1 3 1 5 1 3 1 1. If you find the determinant value, 1 into 5 minus 1 minus 1 into 1 minus 3 plus 3 into 1 minus 15. Answer is 4 plus 2 minus 36. Sorry. (14 into 3) minus 42. 6 minus 42, answer is minus 36. If I check the option, sum of the eigenvalue must be equal to trace, which is equal to sum of the diagonal. Answer is 7. Here option A, if you add, I am not getting 7. Option A is wrong. B, if we add, I am not getting 7. But for C, if we add 6 plus 3, 9 minus 2, 7. And also, if you product these 3 eigenvalue, minus 2 into 3 into 6, answer is minus 36, which is equivalent to our determinant value, that is minus 36. Therefore, for this option, both sum of the diagonals, that is equal to sum of the eigenvalue, which is 7, and also product of the eigenvalue, which is equivalent to minus 36, which is equivalent to determinant. Option C is the correct option, since it satisfies the condition for trace, that is sum of the diagonals, that is equivalent to sum of the eigenvalue, and also the product of the eigenvalue is nothing but our determinant value. Answer is minus 36. For this problem, C option is the correct option. Last option is the wrong option. Option C is the correct one for the fourth problem. Fifth problem, for what values of z does summation n equal to 0 to infinity 3 power minus n z minus 2n converges? Option A, mod z less than or equal to 3. Option B, mod z less than or equal to root 3. Option C, mod z minus 1 less than root 3. Option D, mod z minus 1 less than or equal to root 3. Solution. What is given? Summation n equal to 0 to infinity 3 power minus 1 z minus 1 power 2n. Let us take z minus 1 whole square as some t. Therefore, summation n equal to 0 to infinity 3 power minus n t power n. Here a n is 3 power minus n. Radius of convergence r equal to limit n tends to infinity 1 by supremum of mod a n power 1 by n, which is equivalent to limit n tends to infinity 1 by supremum of modulus of 3 power minus n power 1 by n, which is equivalent to limit n tends to infinity 1 by supremum of 1 by 3 power n power 1 by n, which is equivalent to limit n tends to infinity 1 by supremum of 1 by 3, which is equivalent to 1 by 3 which is equivalent to 3 or equivalent to 3. The series will converge for modulus of t less than 3, that is, which is equivalent to r, radius of convergence. This is our r. What is t? Modulus of z minus 1 whole square less than 3, which implies modulus of z minus 1 less than root 3. For this problem, option C is the correct one. Problem number 6. Which one of the following subspace of R power n. Option A, set of all x1, x2, xn such that x1 plus x2 plus xn equal to 1. Option B, set of all x1, x2, xn such that x1 equal to x2 equal to 0. Option C, set of all x1, x2, xn such that x1 not equal to 0. Option D, set of all x1, x2, xn such that 5x1 minus 9x2 which is equivalent to 6. Options are given option A, option B, option C and option D. From the 4 options, among the 4 you have to choose which one is the subspace of R power n. First option, x1, x2, xn such that if you add all these value, answer is 1. For proving a subspace solution, if we take x1, x2 and xn as 0, 0 plus 0 plus 0 must be 0, but here it is given as 1, not a subspace. Second one, if I take x1 0 which is equivalent to x2 0 which is equivalent to 0, option 2 is a subspace. 3 0 not equal to 0, it is not possible, not a subspace. 5 into 0 minus 9 into 0 which is equivalent to 0, but it is given as 6, not a subspace. For proving a subspace, if you take the values for x1, x2, xn for all the 4 options, I must get answer must be 0. First option, answer is 1 if I add all the values. Second option, it is true, x1 0, x2 0 means answer is 0. See, in the third option, x1 not equal to 0, which is not possible, 0 not equal to 0. But option D also, 5 into 0 minus 9 into 0, it must be 0, but you are given as 6. Therefore, for this problem, option B is the correct option for the 6th problem. 7th problem. Let the curve C be the extremal of the functional I into y of x, it is given x, x1 to x2 f of x comma y dash into dx with suitable boundary condition, then the Legendre condition testing for a weak maximum is option A, f y dash less than 0 on C, option B, f y dash greater than 0 on C, f y dash is constant on C, f y dash should be identically 0 on C. See, this problem is from a calculus of variation. Function is given as integral x1 to x2 f of x comma y dash into dx, and also we have to check which one of the option among the four is a condition which we call it as Legendre condition for testing weak maximum. Solution: for weak maximum f y dash less than 0, for weak minimum f y dash greater than 0. Since the problem is for weak maximum, f y dash must be less than 0. Option A is the correct option. Problem number 8. For a square matrix A which one of the following statement is not true? Option A, 0 is an eigenvalue of A if and only if A is non-singular. Option B, A satisfies its characteristic equation. Option C, A and A transpose have the same eigenvalue. Option D, A into adjoint A, which is equal to determinant of A into I. It is given A is a square matrix. Among the four options, which one of the statement is not true? C. Option B, straight away from the Cayley-Hamilton theorem that every square matrix satisfies its own characteristic equation. Option B is true. C. Option D, this is a result, that is A into adjoint A, which is equivalent to adjoint A into A, which is equivalent to determinant A into I. Option D is also true. For option C, if I take A as identity matrix 1 0 0 1, eigenvalue for A is 1 1. If I find A transpose, again it becomes 1 0 0 1. Again A transpose, once again 1 comma 1. Both A and A transpose same set of eigenvalue. Option C also true. Only first option is false, which is not true. 0 is an eigenvalue of A, then determinant A must be 0 because product of eigenvalue. One of the eigenvalue is 0, determinant value must be 0, since from the result of product of eigenvalue. If determinant A is 0, A is singular, but here it is given as non-singular. Therefore, option A is a false statement, which is a correct option for the 8th problem. Problem number 9. The particular integral of the differential equation where d equal to dou by dou x d dash equal to dou by dou y t minus d dash minus 1 d minus d dash minus 2 of u, which is equal to e power 2x minus y plus x is option A 1 by 2 e power 2x minus y 1 by 2 of x plus 2. Option B 1 by 2 e power 2x minus y plus 1 by 2 x square plus 1 by 2. Option C 1 by 2 e power 2x minus y plus 1 by 2 x plus 3 by 2. Option D e power 2x minus y x plus 3 by 2. We have to find pi for this problem. The problem is given as d minus d dash minus 1 into d minus d dash minus 2 of u, which is equivalent to e power 2x minus y plus x. We have to find from the 4 option which one is the correct option for this problem for finding pi. What is solution? What is given? D minus d dash minus 1 d minus d dash minus 2 of u e power 2x minus y plus x. For finding pi, 1 by d minus d dash minus 1 d minus d dash minus 2 e power 2x minus y plus x. Here what is pi1? 1 by d minus d dash minus 1 d minus d dash minus 2 e power 2x minus y, which is of the form e power ax plus b. A is 2, b is minus 1. Replace d by a, which is equivalent to 2, and d dash by b, which is equivalent to minus 1, which is equivalent to e power 2x minus y divided by 2 minus of minus plus 1 minus 1 2 plus 1 minus 2 plus 1 minus 1 plus 2 minus 2 will get cancelled. 1 by 2 e power 2x minus y. This is for pi1. Now pi2. What is pi2? 1 by d minus d dash minus 1 d minus d dash minus 2 of x. 1 by d dash minus 2 1 by minus 1 1 minus d minus d dash of x. I am taking constant minus 1 outside. can be written as minus 1 by d minus d dash minus 2, 1 minus of d minus d dash power minus 1 into x. This is nothing but 1 minus x power minus 1, 1 plus x square, which is equivalent to minus 1 by d dash minus 2, 1 plus x means d minus d dash dot dot into x, which is equivalent to minus of 1 by d minus d dash minus 2, 1 into x, differentiation of x, that is d is nothing but dou by dou x. Which is 1. Remaining term must be 0. Again take minus 2 outside, 1 minus d minus d dash by 2 of 1 plus x. Minus of minus becomes plus, 1 by 2, 1 minus d minus d dash power minus 1 into 1 plus x, which is equivalent to 1 by 2. Again use the same formula, 1 minus x power minus 1, 1 plus x square. It becomes 1 plus d minus d dash by 2 plus dot 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 into 1 plus x. Take the 1 plus x inside the bracket, it becomes 1 by 2, 1 plus x plus 1 by 2, differentiation of 1 plus x, that is operator. If you use the operator for 1 plus x, answer is 1. Remaining term is 0. Answer is 1 by 2 x plus 3 by 2. This is Pi2. Therefore Pi, which is equivalent to 1 by 2 e power 2x minus y. This is Pi1, 1 by 2 x plus 3 by 2. This is Pi2. For this problem, answer is 1 by 2 e power 2x minus y plus 1 by 2 x plus 3 by 2. Option C is the correct option. Tenth problem in this video. If C is the circle, mod z equal to 2 with the counter clockwise orientation, then integral C 2z minus 1 e power z by z minus 1 dz. Option A 4ie. Option B 4 pi I. Option C 4 pi ie. Option D 4 pi e. The problem is from complex analysis. You have to find the value for the integral 2z minus 1 e power z by z minus 1 dz over c for the circle mod z equal to 2. Option A 4 ie. Option B 4 pi I. Option C 4 pi I e. Option D 4 pi e. Solution. What is given? 2z minus 1 e power z by z minus 1 dz. I am going to rewrite 2z minus 1 e power z as z minus 1 plus 1 by z minus 1, which can be further written as e power z minus 1 by z minus 1 plus 1 by z minus 1. This is nothing but 2z minus 1 e power 1 plus 1 by z minus 1 e power 1 e. You can write further this one as e into e power 1 by z minus 1, which is equal to e into 2z minus 1 e power 1 by z minus 1, which is equal to e 2z minus 1. We know very well what is e power z. 1 plus z by 1 factorial plus z square by 2 factorial from the exponential series e power x. Therefore, e power 1 by z minus 1, we can write it as 1 plus 1 by z minus 1 into 1 by 1 factorial plus 1 by z minus 1 whole square into 1 by 2 factorial dot dot dot. Now find the integral value 2z minus 1 e power z by z minus 1 into dz, that is mod z equal to 2 e into 2z minus 1 1 plus 1 by z minus 1, since 1 factorial is 1, plus 1 by 2 into 1 by z minus 1 the whole square. Into dz. E integral 2z minus 1 into dz. Multiplication of 2z minus 1 with 1 into dz over c, that is mod z equal to 2. This is I1 plus e integral mod z equal to 2z minus 1 by z minus 1 into dz. This is I2 e by 2 integral mod z equal to 2z minus 1 by z minus 1 the whole square dz plus dot dot dot. See this I1, that is integral 2z minus 1 into dz over the circle mod z equal to 2 must be equivalent to 0 by Cauchy theorem. Therefore, E into 0 plus E into, for I2 by applying Cauchy integral formula, z minus 1 equivalent to 0, z equal to 1, that lies inside the circle mod z equal to 2, we can write it as 2 pi into f of a, here a is 1, and what is f of z? 2z minus 1 plus e by 2, this is I3 what is I3? 2z minus 1 by z minus 1 whole square dz. Here apply Cauchy integral formula for higher derivative, that is 2 pi I by 1 factorial into f dash of a, here a also 1. See, for I4 answer is 0 because I4 is e by 3 factorial integral mod z equal to 2z minus 1 by z minus 1 the whole cube dz for I4. Z minus 1 whole cube can be written as z minus 1 power 2 plus 1. For this e power 3, e by 3 factorial 2 pi I f double dash of 1. Here also z equal to 1 is the only one port that lies inside the circle mod z equal to 2. Why I am saying I4 is 0? These two will get cancelled. E by 6 2 pi I. What is f of z? 2z minus 1. What is f dash of z? 2. What is f double dash of z? Which is equivalent to 0. F double dash of z is 0. F double dash of 1 is also 0. Therefore, this is 0. For remaining values, all the values must be equivalent to 0. That is for I5, I6, I7. Here, for this problem, first part 0. I am getting answer for the second part. I am getting answer for the third part. Remaining part I4, I5, I6 will become 0 because only up to f dash of z we are getting answer. Remaining derivative we are getting 0. Therefore, answer is 2 pi I into E f of 1. Here these two will get cancelled. Plus pi I E f dash of 1. F dash of Z is 2. What is f dash of 1? That is also 2. It is equivalent to 2 pi I E. What is f of 1? Since f of Z is 2Z minus 1. For this problem, option C is the correct one. I am getting answer 4 pi I E. Option C is the correct option. This is part 4 of my video for KSET 2013 Mathematical Science question paper. I already uploaded part 1, part 2, part 3. You just go and check the playlist. For part 1, part 2, part 3, I will upload more problems from KSET 2013 Mathematical Science question paper. Subscribe my channel, like my channel, share my channel to your friend. Thank you.